How to make a ghost detector out of a cheap indoor digital TV aerial. I like the way they've added digital in here because obviously it makes a difference. This is out of Poundland, and it's basically a little aerial for adding to cheap TVs to try and get a signal desperately in places that you can't get one, and probably doesn't work that well, but who knows. Inside is the coax. Well, I say coax, I don't know if there's actually, hold on, we'll check that out shortly. I shall desolder these little capacitors. The capacitor onto each of the telescopic antennas in the front, which I've just removed. So just out of interest, is this actually coaxial cable, or is it just a core? No, it's not really coaxial, not unless there's some sort of conductive layer on this outer sheath. Anyway, it's cheap, it's £1, who cares? This is the bit we really want. So the first thing we want to do with this is make a very small indent with a solder iron, because it's quite handy for doing so, right dead centre in the middle here. And this is to aid in the drilling of a hole for an LED. So I'm just going to take a drill, a slightly blunt drill, deliberately so. I'll just make another mark on my table. And then clean the hole up. By just cutting off the little bit of swarf that occurs with a knife, just to clean it up a bit. And that's that bit done. Put the base over there at the moment. Now, what we're going to be doing in here is we're going to put a bit of circuitry between these two antennas, because these are connected straight onto these telescopic antennas. We're going to use the existing lugs. I'm going to get a screwdriver and just loosen these screws and turn them the opposite direction. And I'm going to put a battery compartment. I need a battery. Oh, battery pack. That's something I didn't plan too well, obviously. Oh, where have I put the battery pack? Anyway, we'll come back to that afterwards. The battery pack is going to go in here. It's going to hold 2 AA's. So I'm going to cut these posts off like this to make way for the battery pack, because the type of battery pack I've got is just one that's been salvaged from a set of LED fairlights, owing to the fact that I ran out of battery packs. Now I'm just trying to think where that... I'll tell you what, in the meantime, while I'm just looking for the battery pack, here's the circuit I'm going to be using. I'll let you just browse that for a moment. Well, I salvaged the battery pack from something else. Okay, here we are. Here's the battery pack. The circuit is based on 3 transistors. Now, I've used BC547 transistors because they are a very common transistor in the United Kingdom. They're just the go-to transistor. I think in America you tend to favour the 2N series of transistors, like the 2N2222. I'm not 100% sure. 2N3904? Not 100% sure. But either way, I chose in this instance to use the BC547 because it is the most common. They've got lots of them. And this is its layout as seen from the base of the package. Now, these are just general purpose high gain signal transistors. And there's a few things to note about this circuitry. It's actually a Darlington transistor array. Normally Darlingtons though would just have 2 transistors, but in this case I've got 3 for extra gain. And here's the principle behind the Darlington. All the collectors are common together of a Darlington transistor, and then when a signal is put in the base, it starts conducting slightly, and current flows through the collector and out the emitter and into the base of the next transistor. But because that has a gain, it multiplies the current, which then goes in here as a higher current, which then gets multiplied again, goes through the emitter and into the base and gets multiplied again, and you end up with a super high gain transistor. Now, one end, the input to this, is connected to one of the antennas, and the negative terminal is also connected to antenna to provide a sort of ground reference, a differential between the antennas. There's a LED being used in reverse, so it's reverse biased to provide a very tiny current to help bias this transistor into its conduction region, and that just makes the unit really sensitive to even the slightest disturbance. It's run off a 3-volt supply. The negative goes down to the final output and that end of the antenna, and the positive goes through the indicator LED, through a resistor which is 47 ohms in my instance, and then it goes to the collector, and that's really it. So here's what I'm going to be doing. I'm not going to use a circuit board. I'm going to hardwire it because it's quite a simple circuit, and it's just simple to hardwire it, and sometimes putting something like this in a circuit board can result in slight leakage and conduction across the areas of, with greasy fingerprints. So it's such a high gain circuit that in this instance it suits me to just use discrete components and just tag them across and onto each other. So let's find the components. We're going to use 2 general purpose but fairly bright red LEDs. Strongly recommend red because we're only using 3 volts, and the typical forward voltage of a red is between 2 and 2.5 volt, so it kind of suits this application. One of these, the LEDs are identical. I've also chosen the gallium arsenide technology LED because it's much more stable than the modern gallium nitride ones. These have a very distinctly low leakage, reverse leakage current, which is what we're looking for here. And there's one 47 ohm resistor and the 3 transistors. Now, I'm going to bend all these transistors the same way. I'm going to bend the collector up the way, the emitter to the side, and then the base in the opposite direction. And I'm just going to do that to them all. The arrangement you use will depend on the transistors you can source. And I can't guarantee this circuit will work for all transistors, but it does work for these ones. At least it should work for these ones, so hopefully I'm not going to be made to eat humble pie. Right, so that's the leads bent. I'm going to get some solder now. I'll put the case over there and the battery pack over there at the moment. And I'm going to tin the base and the collector of each transistor. Just smear some solder along the pins. And then I'm going to solder the emitter of one onto the base of the next one. So I'm going to hold them roughly together, and this is where it gets a wee bit footery. And I'm going to reflow that solder to join them together. And then I'll do the same to this one. Okay, now the emitters, I'm going to get a pair of little snipped pliers here. I'm going to bend, shall I say, the collectors. I'm going to bend 2 of the collectors towards each other. They don't all reach, which they're all getting common, but they don't all reach. So I'm just going to solder 2 of them together initially. by touching them together and then a wee splat of solder. That should do nicely. Okay, so now let me think, in case I have a wee brain fart here. So the positive is going to the input of the biasing LED. These LEDs have a very low leakage when they run in reverse. So that's really quite handy here, because even trying something like 10 megohm resistors, too much current flowed. And you think that's just an astronomical sensitivity. So I'm going to use this LED, its negative, as a sort of bus bar to join the collectors together. Just pre-tin them. Flow that. Bit blobby, bit high. It's fine. And while trying not to burn myself, flow this too. Okay, that's good. And the positive is going to the very input, the base, the very first input. Like that, and I'll just crop the excess off that lead for neatness. And this is our super high gain circuit. Now, I've managed to splot solder onto the resistor, but that's alright. This is the indicator LED that's going to be used as the indicator. It's ultimately going to be pressed in here. So I'm going to solder onto its cathode, the negative terminal. I'm going to cut it down and I'm going to solder a resistor onto it. The resistor value here is 47 ohms, and that's just chosen to provide a modest intensity without really drawing too much current, because kind of these things just sit on for quite a while when you're actually using them. I don't actually go on ghost hunts, but I've got a friend who does, and videos it. You'll find his website, walkingwithghosts.com, with lots of video footage of his ghost hunts on it. And he tends to place things like this out and then monitor them over the evening to see if any electrostatic fields pass in the vicinity of the detectors, which is the theory behind them. So there we go. The positive lead of this is just going to be cut short. It's going to actually be the battery positive connection. So now I'm going to press the LED into the hole with the positive connection pointing in the direction of where the battery pack's going to be. I'm going to put some nice fresh lead-based solder onto these crimps, these little terminals. They're not really crimps, they're solder tabs. And then I'm going to solder my module. I'm going to bend that lead away a wee bit, fold these leads round, and then just solder. So that's going to be the negative. Oop, I'll just move that over a wee bit. And this is going to be the input, the sensitive one. Then this resistor gets connected to anywhere along that the collector, the bus of all the transistor collectors. So I'm just going to put it there and solder it. I think everything's still tight. Yep. Crop that. now, the battery pack, I'm going to go and get some double-sided tape to stick that in. And before sticking it in, I'm going to just lightly use some sandpaper to just buff where I'm going to stick it. And likewise, the back of the battery pack, it's got a sliding lid on one side, I shall also buff that to give the double-sided tape something to stick onto. This is what sweatshirts are for. Okay. I might cut a couple of bits because the case is slightly curved. I'm just going to try that, see if it's likely to stick in. Oh, you know what? That should be alright. Yeah, that should be alright, so one bit should be okay. So now I'm going to solder the positive and negative leads on. The negative, well actually I'll solder the positive first, it probably makes more sense. Because the positive solders, I'll put a wee touch of solder on that LED, positive lead. So the positive is going to go to the LED down there. And the negative is going to go onto the antenna tab that the final emitter goes onto. That means that this antenna is effectively referenced to the circuit's ground, and this one is the input, so it lets it see a differential voltage in the air more sensitively. Right, I'm going to stick this in and then we'll find out if it works or not. Double-sided tape, it's a joy to get started sometimes. So let's route the cables out the way of that. And there's a wee switch in this which I shall switch on. Okay. And extend the antennas up. Okie dokie. Now, if there's any electrostatic activity in the vicinity, like me walking about, you'll see that the LED tends to sort of modulate in intensity a little bit. It's not very bright. That may just because I've not actually really got much of a charge on me. I'll try and scuff my feet a bit and try and put a charge in this. The positioning of the antennas is also has quite a significant effect. If you part them like that, the effect is, if anything, I've found it to be slightly less sensitive than just having them both straight up. I'll turn the light off in here because it'll show you the activity more. It's being swamped with the light. I should have used a brighter LED. But as you can see, me just moving about in the vicinity, not actually touching it. At the moment I'm about 3 meters away from that unit. I'm just moving backwards and forwards. And as I move, the intensity of the LED is detecting the field around my body and is actually modulating the LED up and down. Let's try it round that way. Actually, I think it's more sensitive side on. Yeah, but there you go. A very simple ghost detector. Now, to turn it off, because these units aren't 100%. You could put a switch in them, or you could open it up and do the switch inside. But when you've got the lid on, the easiest way to actually turn this off is actually to fold the antennas down and get just a bit of wire, even a bit of solder or something like that, and just wrap it around them, because the bias current is so low that that'll turn it off completely by just pulling the input to ground, and its quiescent current is microamps, it's virtually nothing, so that really is going to have no impact on battery life whatsoever. So there you have it, an electronic ghost detector.